Good morning, everyone. I am Shalami 14 Bungao. I choose the topic linear Diophantine equation. These are the objectives. Provide brief discussion about linear Diophantine equation. State real-life problem about linear Diophantine equation and show complete solution to a real-life problem. So let's have a brief discussion about linear Diophantine equation. A Diophantine equation is any equation in which the solutions are restricted to integers. The word Diophantine is derived from the name of the ancient Greek mathematician Diophantus, who was one of the first people to consider such problems systematically. Diophantus lived in Alexandria around 250 Common Era, and he wrote a textbook called Arithmetica, one of the earliest known manuscripts on algebra. A Diophantine equation is an equation such that only solutions in which all the variables have integral values are considered. A linear Diophantine equation is a Diophantine equation of the form of a sub 1 times x sub 1 plus a sub 2 times x sub 2 plus so on and so forth is equals to c, where the a sub 1s and c are constants and the x sub 1s are variables all raised to the first power. The Diophantine equation is the polynomial equation which the coefficients are integers, and Diophantine equations whose solutions we seek in the set of integers or natural numbers. The most basic Diophantine equation is the linear case. We can write ax plus by is equals to c, where a, b, and c element of integers. Note that let d is equals to GCD of a and b, since a is divisible by d and b divisible by d if c is divisible by d. Then the equation ax plus by is equals to c has a solution. However, the equation ax plus by is equals to c has no solutions if d does not divide c. Based on theorem, the linear Diophantine equation a sub 1 times x sub 1 plus a sub 2 times x sub 2 so on and so forth is equals to c, such that aj or a times j is equals to 0 for some j has a solution if and only if GCD of a sub 1, a sub 2, a sub 3, so on and so forth divides c. Furthermore, where there is a solution, there are infinitely many different solutions. Moreover, if x is equals to x sub 0 and y is equals to y sub 0 is a particular solution of the equation, then all solutions are given by x is equals to x sub 0 plus b over d times t, and y is equals to y sub 0 is equals to plus a over d times t, where t is an integer. Since I'm done with the discussion, let's proceed to the word problem application for linear Diophantine equation. Sergio wants to buy pizza and cola for his family. He has 400 pesos. If we know that each pizza costs 57 pesos and each bottle of cola costs 22 pesos, how many pizzas and bottles of cola he can buy? So we can write the equation as the linear Diophantine equations by 57x plus 22y is equals to 400. Our A is 57 and our B is 22 and our C is 400. So next we're going to have our what they call this one. We're going to find the GCD of our A and B by Euclidean algorithm. So GCD of 57 and 22 using Euclidean algorithm. By the equation of Euclidean algorithm, so x is equals to y cubed plus r. X will be r 57 Then y is 22 for our b. That will be our y. And our q is the quotient of x and y. Then plus r, which is r is the remainder, where r is greater than or equal to 0 and less than y. So our x is 57 is equal to our y is 22. So 57 divided by 22, there will be 2 quotient. So our quotient is 2. So plus 13. 13 as our remainder. So now, from this, we have our new x for the next step. So our new x is 22. And our new y is 13. Where is the remainder from this? So this will be our new y. That will be 13. So 22 divided by 13. So there will be 1 quotient. So from this, we have a 9 remainder. So we have our new x now. Our new x is 13. Then our new y is the remainder, which is 9. So 13 divided by 9, there will be 1 quotient. So plus 4, 4 is our remainder. Now, we have our new x, which is 9. Our new y is 4. Then 9 divided by 4, there will be 2 quotient. The quotient is 2. Then plus 1. 1 is our remainder. Then our new x now is 4. Our new y is 1. So there will be 4. 4 divided by 1, there will be 4. Our quotient is 4. Then there will be 0. There will be no remainder now. So the last non-zero remainder is 1. And 57, 22 is equals to 1. And 400 is divisible by 1. There are many solutions. So there are many solutions since 57 is divisible by 1, 22 is divisible by 1, and RC, which is 400, is divisible by 1. So next is we have our brief guide, which is from our, what do you call this one, from our remainder, last non-zero remainder, which is 1. So 1 is equals to 9 minus 4 times 2. So it's just transpose lang ninyo para mas dali. So this will be our guide for our next step, which is linear combination. So next is our next 4. Next remainder is 4. So 4 is equals to 13, or 1 times 13 minus 9. Okay, next remainder is 9 is equals to 22 minus 13, so on, so forth. So 13, last is 13 is equals to 7 minus 2 times 22. Next is we're going to have our linear combination. So this implies that 57x plus 2y, so our basis is our non-zero remainder. Our last non-zero remainder is 1. So 1 is equals to 9 minus 4 times 2 by this 1. So mani siya tong guide ha. Then so 1 is equals to 9 minus 2 times 13 minus 9. Why is it 13 minus 9? Since our 4, we have 4 remainder, that will be 13 minus 9. So substitute lang nato dire. Then is equals to 1 is equals to 3 times 9. Why 3 times 9? We have 1 9 here, but we're going to multiply this one. Oh, wait sa. So this one, you have 2 9. So we have 3 times 9 now. Minus 2 times 13. So next we're going to substitute. We have 9 here, so we're going to substitute 22 minus 13 here. Next, so 1 is equals to so 22 minus 13, where 9 is equals to 22 minus 13 minus, bring down this one, and minus 2 times 13. Next is there will be 322, right? So we have 313, so plus this 213, so we have minus 5 times 13. So 1 is equals to 3 times 22 minus, we have 13 here. So we have 13 is 57 minus 2 times 22. So we substitute here. Then, so we have 222. So we're going to add this one here. So there will be 1 is equals to 1322. Since 5 times 2, there will be 10. So there will be 1022 plus 3. So it will be 13 times 22 minus 5 times 57. So we can find x sub 0 is equals to negative 5, which is our x is 57. So it will be negative 5. And y sub 0 is equals to 13. Since in 22 there will be 1322. So it implies that also that then x sub 0 is equals to 400 times negative 5, there will be equals to negative 200. And y sub 0 is equals to 400 times 13, that will be 5,200. So this will be, next is, we write the general solution. X is equals to negative 200 plus 22n. And then y is equals to 5 times 200 minus 57. And this will be our x sub 0. This will be our y sub 0. Plus 22n, then 57, and our 22t or 57t by the formula of general solution. So x is greater than or equal to 0, and y is greater than or equal to 0 because x and y determine the number of pizzas and bottles of colas. That's why x and y can't be negative. So 5,200 minus 57n, that will be greater than or equal to 0. Then 5,200 is greater than or equal to 57n. If divide both sides by 57, we find n is less than or equal to 91. So by next is negative 2,000 plus 22n, so that will be greater than or equal to 0. So 22n is greater than or equal to 2,000. So we're going to divide both sides by 22. We get n is greater than or equal to 90 point. So this would be 90.9. Sorry. Or this would be 91. So n is equals to 91. If we put n is equals to 91 in general solution, we find x is equals to negative 2,000 plus 22 times 91 is equals to 2, and y is equals to 5,200 minus 57, and 57 times 91 is equals to 13. So he can buy 2 pizza and 13 bottles of cola in 400 pesos. So thank you.